Hello students, how are you all? Good. Today we are going to start redox reaction. Welcome to your own channel S2 classes, Subra Saraswati classes. This is one of the easiest chapter in chemistry and the name of this chapter is redox reaction. I will try to complete this chapter in 4 to 5 videos, smaller videos, so you will understand. I will not get frustrated because long video will make you tensed, irritation to watch it, open it. So half an hour maximum I will try to complete one topic. And in today's class I will start the rules to find oxidation number and oxidation state. So before starting that, if I ask you what do you mean by oxidation number or what do you mean by oxidation state? ON means oxidation number and OS means oxidation state. So from now onwards I will try to write ON and OS and you will come to know OS or ON means same, oxidation number or oxidation state. So first, the definition of oxidation number and oxidation state is the real or imaginary charge, present on an atom is known as oxidation number or oxidation state. Oxidation number or oxidation state. Suppose I have written Na plus Cl minus Fe2 plus like this. So if I am asking what is the oxidation number or oxidation state of Na, what is the charge present over here? Plus means 1 plus is the oxidation number, oxidation state. What is the oxidation number or oxidation state of Cl? So what you will say? 1 minus. What is the oxidation number or oxidation state of Fe? What you will say? Sir, it has 2 plus, so 2 plus. Now these are the original charge present on an elements, so it is known as real oxidation state or oxidation number. But I have written suppose HCl. Now in this case, is there any charge visible? No, charge is not visible. But as you know that electronegativity of chlorine is greater than electronegativity of hydrogen. So over here hydrogen is taking the electron. No, sorry, chlorine is taking the electron from hydrogen. Because of that, chlorine get negative charge, hydrogen get positive charge. And over here, if anybody is asking what is the oxidation number or oxidation state of hydrogen, so you didn't have to say 0, it is plus 1. What is the oxidation number or oxidation state of chlorine? So minus 1. So this is originally not present. But due to the electronegativity difference, we come to know that the partial positive negative charge and partial positive charge is there. So this type of oxidation number or oxidation state is known as imaginary oxidation number or oxidation state. So originally present is known as real. Due to electronegativity difference, if we will get the oxidation number is known as imaginary oxidation number or oxidation state. Now, as I have told you that in this video, I will try to cover the rules to find oxidation number. So I am going to start the rules to find oxidation number or oxidation state. First rule is saying the oxidation number or oxidation state of hydrogen is, H means hydrogen, is usually, whenever I am writing usually, it means not in 100% cases. Usually means in some cases that there will be little bit change. It means whenever I am writing always, means always this is usually, it means some exception is there. So usually you will get the oxidation state of hydrogen is plus 1. But in case of metal hydride, when the hydrogen is attached with metal, the oxidation number or oxidation state of hydrogen is -1. It means suppose any metal LiH, in this Li has 1 plus oxidation number, hydrogen has 1 minus. MgH2, so you will draw the structure MgHH, it get negative, it get positive, it get negative, it get positive. The oxidation number or oxidation state, oxidation number or oxidation state of magnesium, so one magnesium has 1 plus became 2 plus. What is the oxidation number or oxidation state of hydrogen? So you will, this is the for magnesium. So you will say, sir, this hydrogen has 1 minus, this hydrogen has 1 minus. Individually, they don't add it. If the charge is on the same element, then add. Different, then it has oxidation number as -1. It means only in the case of metal hydride, the oxidation number of hydrogen is -1. Otherwise, in every cases, you will have to take the oxidation number of hydrogen is +1. This is the first case. Now, you have written this part. If you want to write, I'm just going to erase this 1, 2, 3. Now, we are going to see the second rule to find the oxidation number or oxidation state. And in this video, we will complete the rules. And in the next video, I will solve 20-30 question, an important type of question from IIT JEE, MTC book, this are publication, any book, there is a question. Second rule, that the oxidation number or oxidation state of oxygen is usually -2. Usually it is -2. Acha, before writing the point, if I write O2, 2 minus, what does it means? 2 oxygen is there, on that 2 oxygen, total charge is 2 minus. So after breaking it, what is the charge on 1 oxygen? 1 minus. Not getting? If I am writing O2, 1 minus, on 2 oxygen, there is a charge of 1 minus. So what is the charge on 1 oxygen according to this? So -1/2, half on 1 oxygen, because on 2 oxygen there is, suppose I have written O2 1 plus. What is the charge on 2 oxygen? 1 plus. So what is the charge on 1 oxygen in this case? So +1/2. Suppose I have written O3 1 minus. So what is the charge on 1 oxygen? So 1 minus. So what is the charge on 3 oxygen? 1 minus. So what is the charge on 1 oxygen? So -1/3. Getting this point? Okay, now start with the topic of oxygen, because this is going to be important. Now it is saying that the oxidation number or oxidation state of oxygen is usually -2, but -2 in case of oxide, and oxide is O2 minus. Second one is saying in case of peroxide. Peroxide is O2, 2 minus. So if O2 has 2 minus, then how many oxidation number of 1 oxygen? What is the oxidation number of 1 oxygen? So 1 oxygen has -1. 1 oxygen has 2 minus, so oxidation number is -2. 2 oxygen has 2 minus, so 1 oxygen has oxidation number as -1. So third one, in case of superoxide. In case of superoxide. Superoxide is written as O2 1 minus. The 2 oxygen has 1 minus, the 1 oxygen has -1/2. These are the exception. It means oxygen usually has -2. But in case of oxide, it is -2. In case of peroxide, it is -1, because 2 oxygen has 2 minus, the 1 oxygen has -1. In case of superoxide, it is O2 oxygen has 1 minus, the 1 oxygen has -1/2. In case of ozonide, ozonide is O3 1 minus. Ozonide is O3 1 minus. So 3 oxygen has 1 minus, then 1 oxygen has -1/3. Then in case of O2 plus, 2 oxygen has 1 plus, so 1 oxygen has +1/2. In case of OF2, OF2 is something like FOF. Now, in this case, we know that fluorine is most electronegative atom. So this fluorine has always -1, always -1. So because of this oxygen get 1 plus. Then this fluorine also has -1. Because of that, this oxygen get +1. What is the oxidation state of oxygen in case of OF2? So 1 plus 1, that is +2. Now in case of O2F2, in case of O2F2, O2F2 is FOOF. Now this F has 1 minus because most electronegative than oxygen. So this oxygen has 1 plus. This F has 1 minus. So this oxygen has 1 plus. It means what is the oxidation state of this oxygen? +1. This oxygen +1. Individual over here +1 on same oxygen. So I have added over here individually +1, individually +1. It means +1. So these are the special cases of oxygen in which you have to learn the oxidation number. It means oxygen has usually -2. In case of oxide it is -2. In case of peroxide it is -1. In case of superoxide it is -1/2. In case of ozonide it is -1/3. In case of O2 plus it is +1/2. In case of OF2 it is +2. In case of O2F2 it is +1. Now before going to the next point, we will have to know about peroxy linkage. What is peroxy linkage or peroxy bond? What do you mean by peroxy linkage and what do you mean by peroxy bond? So suppose oxygen bond is there, and with this oxygen there is -1 charge, and with this oxygen there is -1 charge. This condition is known as peroxy linkage. So if I asking that we will have O2 2 minus. If you break it, you will get O and O. 2 oxygen has 1 bond. Now 2 oxygen has 2 minus, so 1 oxygen get -1, another will get -1. It is peroxy linkage, yes. If I draw the structure of O2F2, F, O, O, F. Now it has +1. Because of that it has +1. It has -1. Because of that it has +1. So this oxygen bond is there. Peroxy linkage means there is a bond between oxygen. Now with the oxygen there is negative charge, one negative. But over here there is a bond between oxygen. But does this oxygen has negative charge? It has 1 plus. It means it is not the peroxy linkage. So you will understand peroxy linkage. So these are the points regarding oxygen. Now we are proceeding with the third point. First rule, we have seen that usually +1 for hydrogen. Only in case of metal hydride, oxygen has usually -2. These are the special cases, ozonide, peroxide, oxide. These are the cases in which there is no any usually things like -2, different things. But only in these cases, usually you will have to take -2. And you understand peroxy linkage. If you want to write this part. I am going to erase over here and I am writing the third rules to find the oxidation number or oxidation state. I am going to write the third rule to find the oxidation number and oxidation state. And it's my request to you all that if you find anything lengthy or not able to understand the things that I am dictating, you will comment me on comment box and I will try to resolve your problem. Now the third rule we will have that the oxidation number or the oxidation state of fluorine is, I am writing always means no exception, always -1. Why? It is the most electronegative element in whole periodic table, so it will always reduce -1 taking the charge. Next point, the oxidation number or oxidation state of halogen. Halogen, you know, group 17 element, fluorine, chlorine, bromine and iodine. So fluorine rule we have already written. So the oxidation number or oxidation state of halogen except fluorine is usually, over here always, over here usually means some exception, usually -1, but it vary from -1 to +7. It means the oxidation state of halogen group is usually In most of the cases it is -1, but it can varies from -1 to +7. Anything -1, 0, 1, 2, 3, 4, 5, 6 up to 7. We will solve the question, and according to that we will come to know where the halogen, chlorine, bromine, iodine has +1, where 0, where +2, like that. Now the next point we will have, these are the rules. First write the rule as it is. Then whenever we will do the question, I will tell you I have written this rule, I have written this rule, like that, and no need to learn this rule. Trust me, after doing lots of questions, this rule is going to be memorized. I am already memorized it now. I am writing without saying anything. So does I have learned it? No. After doing all the questions, you will come to know. Next point, that the oxidation number or the oxidation state of alkali metal. And what is alkali metal? Group 1 is always, whenever I am writing, always means no exception, always +1. The oxidation state or oxidation number of alkali metal group 1 is always 1. Next point, the oxidation number or oxidation state of alkaline earth metal is always, again I am writing always. Always means 100%. Usually means sometime varies, sometime different. Always +2. The oxidation number and oxidation state of alkaline earth metal is always +2. Right? This point you have already written. Can I erase this? Okay. Now come to the next point. Understanding the things, don't worry if you are not understanding. After doing the question, once I will complete the rules, then in the next video I will do 20, 30 questions, 40 questions, 50 questions, up to which you are not satisfied, and I will try to do that question within half an hour, like that. Now the next point we will have seventh number. Seventh point is saying that the oxidation state or oxidation number of metal in free state. Free state, or it is also known as elemental state. It means naturally occurring state is 0. Is 0. Suppose I have written NaCl2 chlorine, gases are diatomic, Cl2, F2. So in these cases, fluorine, not F2, fluorine has -1. F2, if any element metal is found in natural state, where the nature has given their state. We know that gases are diatomic, so I have written over here. Like Li, they have the oxidation state as 0 if they are found in natural state. Now the next point we will have the oxidation number or oxidation state of metal may be sometime negative. How? Always you know that metal always loses electron. So metal has, as you have seen, metal hydride, hydrogen has negative, metal has positive. But some cases metal has negative oxidation number also. Suppose I have written the example Na, over here suppose FeCN whole twice this. Now you know that in this case, first of all write that oxidation number or oxidation state of neutral compound. Neutral compound. Oxidation number or oxidation state of neutral compound is 0. Neutral compound is, over here suppose I have written CO. Neutral compound is CO. NH3, H2O, they have the oxidation number as 0. If you find the oxidation number over here, everyone knows that sodium metal has +1. Plus over here iron has X, I have taken. Cobalt, not cobalt, sorry, carbon monoxide, CO. Cobalt is CO like this. So it is carbon monoxide. It is neutral species, so 0 into 2 is equals to 0. From here you will get 1 plus X is equals to 0. So X you will get -1. And this is the oxidation number or oxidation state of iron. And iron is a metal. So sometimes the oxidation number or the oxidation state of metal is negative, but some of the rare or rarest cases, and after knowing the solution you will come to know. So these are the some point. Write fast, then I will erase it. I am going to erase it, written. Now the next rule, write fast this part. Now the next rule we will have, rule number 9. And again I am saying no need to learn this rule, because once started doing the question, you will come to know how to understand the rules. Rules is not about to learn. Learning of rule is the wastage of time. Okay, so you will not learn it. Question point number 9. It is saying that the oxidation number or oxidation state of any element in free state or elemental state, any element in free state or elemental state is 0. Like O2, Cl2, H2, S8, P4, this is white color, or carbon of graphite or carbon diamond. These all have the oxidation number 0. It means oxidation number or oxidation state of any element in free state or elemental state is 0, as well as in allotropic form. Allotropic form is 0. Allotropic form means graphite is made up of carbon. It means graphite is a allotropes of carbon. So if anything find in the allotropic form or in the original elemental state, free state, then their oxidation number is 0. Next point we will have the oxidation number or oxidation state of alloy. Do you know what do you mean by alloy? Alloy is a compound that is mixture of 2 or more metals is 0. Suppose I have make sodium amalgam, mercury amalgam. Now if anybody is asking what is the oxidation state of sodium, 0, amalgam 0, 0, 0. So in alloy form the oxidation number is also 0. This part I think you have already written. Now come to the next part. Write this point as it is. Whenever we are doing the question, it is going to be very, sir, please don't say that batch. Now the next point we will have the sum of oxidation number or oxidation state of each element in a compound is 0. The sum of oxidation number or oxidation state in each element in a compound is 0. What does it mean? Suppose I have written HNO3. What is the oxidation state of hydrogen? 1. Nitrogen, I will write it -3. Oxygen 3 into -2. If you over here HNO3, what is HNO3 over here? What it is? 1 -3 -6. What you will get? 1 nitrogen. Oh, sorry. One second. I will take the another example because I have not written about the nitrogen. It is saying that, understand, don't get worried about that. I will tell you. The sum of the oxidation number or oxidation state of each element in a compound is 0. Suppose I have written, or one point I will add, then it is easy to make you understand. Just wait. The sum of oxidation number or oxidation state of each element in a compound is equal to the charge present on that compound. Now I will repeat that both point. Don't get confused. Up to that any problem? No sir. Okay. What I am trying to say. Suppose I have taken over here SO4 2 minus, and over here same example HNO3. So first find the oxidation number of nitrogen, because nitrogen oxidation number varies. I will write. So 1 plus X plus 3 into -2. The total charge is 0. Now 1 plus X minus 6 is 0. So it means X you will get plus 5. Now hydrogen has 1, nitrogen has plus 5, plus oxygen has minus 2, and oxygen has minus 2, 3 oxygen. So minus 2, what you will get? 1 plus 5 minus 6 is 6 minus 6 is 0. It means whatever be the oxidation number of each element, hydrogen, nitrogen, oxygen, and add it, whatever be the charge over all in this compound is 0. It is coming to be 0. Suppose I have taken SO4 2 minus. So first find S. You will say x plus 4 into minus 2 is minus 2. So x minus 8 is minus 2. X you will get plus 6. It means sulfur has plus 6. Oxygen has minus 2 to plus 6. Minus 2 into 4. What you will get? 6 minus 8, that is minus 2. What I am trying to say, the oxidation number of the sum of the oxidation number of each element in a compound is either 0 because their overall charge is 0, or either their charge present on it. If you see it, minus 2, over here plus 5. Getting it? Now, because nitrogen oxidation number we didn't know. Now come to the 12th point. This part written, write fast. Now, I will tell you, if you not understanding the point over here, any point if you get confused, then whenever we are doing the question, I will make that sorted out. Don't worry about that. Okay. Now the next point, we will have the point number 13. It is saying that the oxidation number or oxidation state of nitrogen is usually minus 3, but it vary from minus 3 to plus 5. It means usually in all of the cases you will have to take minus 3, but sometimes it varies from minus 3 to 5, like that. Over here the nitrogen has plus 5. Getting this point? Now come to the point number 14. Point number 14 is saying that oxidation number or oxidation state in ionic bond. So it is saying that charge on cation is oxidation number or oxidation state of cation. Whatever be the charge present on cation is considered to be the oxidation number or oxidation state of that cation. And the next point, charge on anion is considered to be the oxidation number or oxidation state of anion. What does it mean? Suppose I have written NaCl. If you break Na plus Cl minus. So what is the charge of cation? 1 plus. The oxidation number or oxidation state of Na is cation is 1 plus. What is the oxidation number or oxidation state of Cl? To 1 minus. Suppose I have written over here AlCl3. This is ionic bond. If you break it, Al3 plus 3Cl minus. What is the charge on the cation? 3. So aluminum has oxidation number or oxidation state as plus 3. What is the charge on anion? Whenever you are counting the charge coefficient, you also have to take. So what is the oxidation number or oxidation state of chlorine? Minus 3. Getting it? So likewise, we will find the oxidation number or oxidation state in ionic bond. Now the next point we will have written, this part can be erased. Write fast. Okay. It is a video. Whenever I am writing anything and you are not able to, just then pause the video and write it down. Go to the back. This is not the offline classes. Now the 15th point we will have the oxidation number or oxidation state of the oxidation number and oxidation state in, not of, in covalent bond. The oxidation number or oxidation state in covalent bond. So what is the rule? It is saying that in this you should have to be familiar that electronegativity. If you form a covalent bond, there is an electronegativity difference. If not, then not. I will tell you. Suppose I have taken electronegativity of B is greater than electronegativity of A. Now I am forming A double bond A triple bond A. Over here I am forming A single bond B, A double bond B, A triple bond B. If this bond break, 0 oxidation number because there is no any electronegativity difference. Over here 0 over here 0 because electronegativity difference is not there. But if you see over here, it will break. Which is more electronegative? B. So it will get 1 minus, it will get 1 plus because one bond is there. If it will break, how many bond? 2 bond. So more electronegative will get 2 minus, less electronegative will get 2 plus. If it will break, more electronegative will get 3 minus because 3 bond is there, and less electronegative will get 3 plus. Suppose I have told you electronegativity of A is now greater than electronegativity of B. And over here A single bond B, A double bond B, A triple bond B. Now it will break. So A is more electronegative. The more electronegative, previously A is less. So A is getting positive. Over here A will get negative, B will get positive. Over here double bond, so 2 negative, 2 positive. Over here triple bond, 3 negative, 3 positive. Understand? Now come to the next point. Written this part. Now come to the next point. That next point is the last point of this class. After that, we will complete the rules for oxidation number or oxidation state. Then in the next video, I will go with another thing to find the oxidation number calculation. And the next rule is rule number 16. Rule number 16, we will have to find the oxidation number or oxidation state of coordinate bond. The oxidation number or oxidation state of coordinate bond. In coordinate bond, if I give you electronegativity of A or B, suppose B is greater than electronegativity of A. Getting it? Right first. So if I am taking the same thing like, suppose we will have A coordinate bond with suppose A. Second A coordinate bond with B. A coordinate bond B coordinate bond with B. Then we will have B coordinate bond with A like this. Now in this coordinate bond, same but still forming coordinate bond. So where the arrow is going, over there they will get 2 minus because 2 lone pair of electron giving the coordinate bond. And from where the arrow going, we will get 2 plus. Over here again breaking, arrow coming over here, 2 minus, 2 plus. Same again 2 plus 2 minus. But in this case over here B is more electronegative. It is going from high electronegative to low electronegative. Over here AA, no problem. AB, B is more electronegative, arrow is over here, no problem. Over here BB, no problem, it will break. But over here B has more electronegative and it will form the coordinate bond like this. It is not possible. So over here oxidation number is 0. So suppose if I draw the structure C like this, and because we know that over here we will have like this. We know that in cyanide group 2 bond is formed as a covalent bond and 1 bond is formed as a coordinate bond. Now does this coordinate bond will give the oxidation number? No. Why sir? Because it is going from high electronegative to low electronegative. So no. But because of this 2 double bond, it will get 2 negative, 2 negative and over here 2 positive. Getting everything? Is there any problem? Sure short. Write all the things, then we will complete the video. Now as you have written all the things, coordinate bond will, suppose more example not needed. Understand na? This coordinate bond is not formed. Now with the double bond it will break. So more electronegative will get 2 minus, less electronegative will get 2 plus because 2 double bond is breaking. So likewise like this I have done over here with the double bond. So like this I have completed the rules to find the oxidation number and oxidation state. Now if you understand this topic easily, then no problem. If you find it any difficulty, we will do the question on that basis, and I trust that you will not find any difficulty over there. Then bye, have a nice day, enjoy, take care and study hard and get selected. Bye.